At this point, the telescope isn't exactly a new invention in itself. We've had it for centuries now, and perhaps more than any other astronomer in history, it was Galileo Galilei who first decided to point it skyward, to begin in earnest studying the stars. For Galileo, and for so many years after him, however, these were simple ground-based steps. It wasn't until the mid-20th century, as technology fast-tracked, that science realized how observations positioned in space offer a much better view of the universe. The first successful space telescope was launched in 1968, the American Orbiting Astronomical Observatory 2. And since then, we've seen increasingly advanced variations, up to and including some of the supremely powerful instruments that are still in orbit today, like the Chandra X-ray Observatory and the Hubble. But none of these can accomplish quite what the James Webb Telescope can, which is why it's one of the most anticipated space missions, period, ever to launch, and has been variously heralded as ushering in a new age for cosmos exploration. In short, the Webb is so important because it's the most powerful space telescope ever built, and operating in the infrared spectrum of light, it will enable us to see further than ever before. Webb is also the largest space telescope ever launched, which brings with it a unique challenge, given its infrared speciality. Tools that see in infrared need to be kept extremely cold, and that's somewhat difficult, as the sun is obviously an ever-present in the solar system. In order to stay cold then, the Webb requires an advanced cooling system and a massive shield, on account of its size. At the same time though, Webb depends on solar energy for power, so it's a huge and complex balancing act. The telescope has to juggle gathering direct sunlight while also staying cool. And yet, thanks to that shield and the cutting-edge engineering that runs right the way through it, there have been no problems so far. The Webb successfully launched on Christmas Day, December 25th in 2021 from the European Space Agency's Kourou launch site in French Guiana, and the payload's long path ahead began on an extremely positive note. Due to a very successful and accurate launch, NASA announced post-launch that Webb would have enough fuel left in the tank to effectively double its mission life expectancy, with it now expected to run for significantly more than a decade. So, right from the beginning, success was in the air. As Webb left the atmosphere, a camera on board the Ariane 5 rocket that carried it into space caught sight of it one last time, disappearing into the darkness. Its destination wasn't a planet or star though, but something called a Lagrange point, which is an area in space where the gravity and centripetal force of the Sun and Earth effectively cancel each other out, which creates a kind of stable zone. The specific Lagrange points that Webb traveled to is called L2. It arrived in late January 2022 and is now located as though behind the Earth, and therefore further from the Sun than we are. This particular position means that the telescope will follow Earth in orbit and will stay a constant almost 1 million miles away from us. A massive distance that's also necessary to ensure that Earth's own heat and light emissions don't contaminate Webb's view of space. The journey to L2 wasn't simply a case of A to B, however. The Webb was launched in an initially compact form, so mission runners have had to pull off a series of complicated and unprecedented unfurling processes to get the machine into its target shape and operational. One of the most important steps came just 3 days after launch, when the sun shield was deployed. This is that key part of Webb tasked with providing a barrier between it and the sun's intense heat, or else the telescope would not be able to retain its vision. With the fully extended sun shield being about the same size as a tennis court, it took some 4 days in total to get it ready, with the final tensioning of its membrane taking place about a week post-launch. The next major milestone came with the deployment of the telescope's mirrors, which served to reflect light directly into its central eye. There were 18 primary segments to deploy, as well as a handful of secondary mirrors, and it was announced that all had been successfully initiated on January 19, 2022. There next followed a main trajectory burn to alter Webb's course and to ensure it stayed on the right track, which was yet another crucial moment that could have easily gone wrong, but was executed perfectly. In total, it took 30 days for the telescope to reach its destination and settle into what's known as a halo orbit at L2. At that point, it was ready to begin final preparations to start its main mission objective, gazing into the universe. This meant aligning, calibrating, and cooling all the instruments, and Webb achieved these feats over the next few months. On March 16th, it was announced that it had successfully aligned its mirrors and officially turned on its optics. And then, on April 13th, the mid-infrared instrument on board was cooled to a sufficient temperature for the first time at just a few degrees above absolute zero, and essentially the coldest that anything can get. Clearly, the sun shield was working. So now, with everything in position, optics aligned, and key instruments cooled, was the Webb finally ready to begin? Not quite. There are more tools on board, including cameras, spectrographs, and imagers, which all have different modes of operation that need to be checked, rechecked, and tested. And in the remaining months before the final switch on, this was what the team on the ground busied themselves with, meticulously trialing and fine-tuning all of the Webb's gadgets before finally pressing play, for real, on one of the most innovative, exciting, and expensive astronomy missions ever seen. Often, a mission as big and budget-heavy as this one can find itself dogged by problems, niggles, and false starts. And let's not forget, this was the case before Webb got off the ground, with various issues causing delays to the launch itself. But since then, it's been remarkably plain sailing for astronomy's new favorite toy. There were countless things that could have gone wrong at almost every step of the way. The launch could have failed. The sun shield might have collapsed. The ejection burn could have messed up its position entirely. But so far, so good. The Webb has performed every action nearly perfectly. And while there are still many problems that could arise from this point onward, confidence in Webb is growing and growing. From here, it's little wonder that there's such a race amongst astronomers to get some time working with Webb. NASA has outlined its 4 main objectives as 1. Exploring the very beginning of the universe. 2. Viewing the birth and formation of early galaxies. 3. Seeing the birth of stars and protoplanetary systems. And 4. Uncovering more about the origin of life itself. Those are extremely high targets, but one that Webb is expected to meet. It's been a long time coming, and we're very nearly ready to see completely new parts of the universe. And that's everything the James Webb Space Telescope has achieved so far.